Okay, folks, so what I want to do with this video is show you how to make some histograms in R, really how R handles histograms, and also how to make them a lot better with a little bit of code. So what I've got here, I'm using the same wolf population that we looked at last week in class, and I've also got some parameters for the Siberian Husky here, so we have a mean and standard deviation for those as well. There's a different activity where you compare those. But in this one, let's just look at these graphically. So what I've done is the same thing I've done in other activities. I have the parameters set, and I've got a sample size here on line 10, and then on line 13 and 14, I actually create two samples. So it's going to grab 30 wolves from the population. It's going to grab 30 huskies from the population so that we have those to work with. It isn't going to print us those out because we don't need to actually see those numbers here. But what it's going to do when I run this program is down here at the end on line 19 and 20, it's going to create a histogram of both of those samples, the wolf sample and the husky sample. If you haven't used Replit before, the place that Replit stores these is over on the left side under Files. There's this new file created called rplots.pdf. And basically it prints out each of your histograms on this. Great, cool. The only downside is that right now, say you're using this for a class activity or something, they're really hard to compare. So looking at the wolves histogram, this ranges from 70 to 140 pounds on the y-axis. The frequency, it looks like, goes up to about 9 or so. The husky y-axis is actually on the same scale, but the x-axis is super different. So we go from 35 to 65. You could definitely hand this to a class, but in some cases it would be more difficult to compare those distributions because of all the different numbers, and that might be an obstacle that you needed to overcome, which isn't really what you're trying to teach there. So a couple things that you could do to fix this. First of all, we could set we could use a parameter in this histogram function to set the same limits on x for both of these samples. So what I could do is say x limit is from 0 to 150 for both of them. And what this is going to do is say, hey, no matter what you get in the sample, I want you to show me a histogram that goes from 0 to 150. So if I run this again, and we are going to get slightly different values, we get two new plots. And you'll notice that now there are some things that are different, but the x bounds are the same. We go from 0 to 150 for the wolves and 0 to 150 for the huskies. Now, a couple tricks here. First of all, the frequencies are now different. You see that the wolf graph goes up to 10, the husky goes up to 9, and actually the huskies actually cap at 8, but there's a point beyond that. So we can fix that too. The way I'm going to fix that is set a y limit. I'm going to say those should go from 0 to 30. There's 30 in each sample, so the max possible height I could get out of a frequency would be 30. So I'm going to just say both of them should look like that. And now we're starting to get things that are a little more comparable. And what I mean by that is that the height on this top plot means the same thing as the height on the bottom plot. Here's the trickiest part of the whole thing. Is R is not doing the bins in the way that you might expect. For the wolves, we see 1, 2, 3, 4, 5 bins between 50 and 100, so I think that's going every 10. In the huskies, I can't really tell what's up, but I already see 1, 2, 3, 4, 5 in the first half, so it's probably going every 5 in the huskies. R does this in its different histograms to try to make things as pretty as possible, but we have a way to force it to do the breaks exactly where we want them. I'm going to have R do the breaks every 5, and what I've done is I've pre-written this line of code that's basically going to set the breaks every 5 manually. There are cleaner ways to do this, but I want to just show you how to do kind of exactly this to get exactly the same plot in both cases. So this would give you, what this will do is set a break or a bin width every 5 units on the x-axis. Oops, this should be breaks equals breaker. And again, I just did this ahead of time so that I didn't have to type this all out in the moment. But I have manually specified every 5 units between 0 and 150, which are our x limit. So let's set this, or run this, and see what happens. So what we should have now are two histograms where the breaks are exactly the same, the x length is exactly the same, the y limits are exactly the same, and we should be able to directly compare these. Like all the information is directly comparable. If one's taller, that means there's more observations at that point. And you can clearly see that like the center of the Huskies is more like 50, the center of the Wolves is maybe like 90, somewhere here. And I think that's a lot easier to see. Now, a couple other prettyification things that you might want to do are things like a graph title and axis labels. You can set a title by doing main equals something, an x label, x-axis label by saying x lab equals something. So maybe I'll say weight here. And y label can just be, maybe I'll call that counts. And again, that would be y lab equals something. I'm going to do the same for the Huskies graph, except of course I'm going to make this Husky weights. And just for the heck of it, I'm going to also set this graph to be blue so that you can see how that works. And then maybe students could tell those graphs apart. So what we have now is a graph called wolf weights. It's got counts on the y-axis, weight on the x-axis. Same for the Husky weights, except those are now in blue. So that's pretty much all the basic things you need to know to tweak around a histogram in R.